In a few cases, you can inherit this, but for the most part, you don't inherit these diseases. There's got to be environmental triggers or causes. Okay, and after many decades, we still do not have a good understanding of what those environmental causes are. Okay. The one exception here is Huntington's disease. That is 100% genetic. We know the gene involved that. You do that, inherit that. Okay. So again, these are these characteristic protein tangles that accumulate in your brain with these diseases. Okay, how did this get discovered? Well, the result of an unusual, tragic event after World War II on the island of Guam. Okay. During World War II, as the Americans and Japanese were fighting over the islands of the Western Pacific, including Guam, the native Chamorro people of Guam had to greatly alter their lifestyle and so on, and they didn't have a whole lot of food. There was a major change in their diet, and they started eating a lot of fruit bats. Okay? And basically what they did after World War II, this was an estimated abundance of fruit bats on the island of Guam. They drove those fruit bats to extinction. Okay? On the island of Guam. About 20 years after this massive consumption of fruit bats, you see about 150-fold increase in the incidence of these neurodegenerative diseases among the native Chamorro people. Something like 20% of the people died from these neurodegenerative diseases. Okay? So this is a unique situation because in this case, these people stay in one location. They're not moving around. They stay on the island of Guam. They have a unique diet. The Americans and other Asians that lived on the island of Guam did not come down with these neurodegenerative diseases, just the native Chamorro people, and they had a unique diet. So here's a chance to finally figure out what the environmental factor would be. And for many decades, the medical community could not figure it out. Okay? And then only like 15, 20, well, maybe close to 20 years ago now, an ethnobotanist by the name of Paul Cox came along, took a totally different approach. He actually went and lived with the people, learned their language, their lifestyle, and so on. And he came up with this really kind of crazy hypothesis. We call it the Batty hypothesis. What he discovered was there were cyanobacteria, these are blue-green algae, growing on the superficial roots of these cycad trees, and they're producing BMAA. And this toxin, BMAA, gets into the cycads and biomagnifies. It gets concentrated into the cycads and into the seeds of these cycads. And the fruit bats, Paul calls them flying foxes, but biologically they are fruit bats, okay? Fruit bats then are eating the seeds of the cycads and they get a huge dose of the BMA. So you get this really high concentration of BMA in these fruit bats. So it was during and after World War II that, I should say primarily during World War II, that the native Chamorro people were eating lots of these fruit bats, getting a big dose of BMAA. And then 20 years later, you see this huge increase, 150-fold increase in incidence of these neurodegenerative diseases. Okay, so that's what led, this hypothesis here is what led into our research now on BMA. And I want you to remember this number here, 3,500. Okay, this is the amount of BMA in the brains of people who died on the island of Guam, the Chamorro people. You see high levels of BMA in their brains. And here's your controls. Here's Canadians who died of something else. And no, you do not see BMA there. So normally you would not have BMA in your brain. So that makes sense. But here's 2 Canadians who died of Alzheimer's. And presumably they were not eating fruit bats from Guam. And yet you see BMA in their brain. So this suggests, well, this is not just this really unique, kind of weird food chain on the island of Guam. There's other ways of getting BMA in the brain. So sure enough, my colleague, Deborah Mash at the University of Miami Medical School, she runs the brain bank there. She took a bunch of Americans, now who are presumably not eating fruit bats from Guam, takes Americans who've died of ALS and Alzheimer's, and sure enough, you see high levels of BMA in their brains. Here's your controls. People died of something else, no BMA. Now, you can still argue cause and effect. What's cause, what's effect? I mean, you could argue that if you've got a neurodegenerative disease that causes your brain to accumulate BMAA. Well, that's where Huntington's disease comes in. Remember, that's 100% genetic. yet no BMA. So it tells you the direction here. I mean, it's the BMA leading to neurodegenerative disease, not the opposite. Okay, so it's when I saw those data. I mean, again, these people, there's obviously another pathway besides fruit bats for getting BMA in your brain. And of course, I just showed, I've been studying these blooms of blue-green algae here in South Florida. So the question is, are they producing BMAA as well? And could that be getting in the food chain, seafood that we're eating? So let's go back to Florida Bay. I got a couple of shrimp that from right in this bloom here. 2 shrimp. Here's one, 3,000. Almost as high as the fruit bats of Guam. Here's another one, 1,500, about half that of the fruit bats of Guam. Okay, I didn't talk about the cause of this bloom here, but this is southern Biscayne Bay, eastern Florida Bay. For some of you who know the area, this is what's called the 18-mile stretch. This is the causeway that goes from the mainland down to Key Largo here. That's how you get down to Florida Keys. And in 2005, the state of Florida decided to bulldoze all the mangroves along there. And I won't go into the details of this, but basically, after they bulldoze all the mangroves, you get this huge bloom of blue-green algae. So this is abundance of algae before the bulldozing of the mangroves, and here it is after. You get this massive bloom, and it lasts for like about 2 to 3 years. Now, I was not working on the hypothesis of BMA at the time, so I don't really have any good samples, but when I got interested in this, I asked around. I did have a colleague who was doing a study up in here, right on the edge of the bloom, and it was after the bloom, so it was really not a very good sample. But this was a way of just testing, would you still have lingering effects after the bloom is gone, basically at the edge, okay? And so the result is you get a lot of variability here, okay? But here's a blue crab, 7,000, twice as high as the fruit bats of Guam. Another one, 5,000. Here's a puffer fish, close to 7,000, okay? Clusatchie River, got a showed you this slide. Okay, here's some fish, and they are ranging from 500 to 2,500, something like that. Okay, you also have all this nutrient-rich water from Lake Okeechobee going down the St. Lucie Canal into the St. Lucie Estuary and into the Indian River Lagoon. Okay, and so there I wanted to go to the very top of the food chain, in this case bottlenose dolphins. Okay. They're an endangered species, so I had to get a permit to get brain tissue from them. But the advantage is, because it's an endangered species, every time they find a dead dolphin, they have to do a full autopsy to find out what killed it. Okay. This just shows you that guacamole bloom. So here's 6 dolphins. Here's a dolphin here, no BMA in its brain. The autopsy showed it had been hit by a boat. The other 5 here have high levels of BMA similar to what you see in humans who have died of these neurodegenerative diseases. Okay. The autopsies could not find any obvious cause of death. Okay. We've now since gone back, and you do find these protein tangles in their brains. Okay. And I've talked to a couple of people who actually study the behavior of dolphins in the Indian River Lagoon. They've told me they've seen dolphins that they seem to be getting lost, just sort of wandering around, sometimes swim up the rivers and the freshwater lakes and stuff. Sounds just like an Alzheimer's patient, just sort of wandering around or something. Okay, well, since then, I'm not going to show the data, but basically, since then, people did other studies, feeding BMA to monkeys, and sure enough, you see the protein tangles develop once you start feeding them with BMA. And also, you do statistical studies. A colleague of mine up at Dartmouth has done a study of the lakes up in New England. People who live near lakes that get blue-green algae blooms have a 25-fold greater chance of coming down with ALS than if you don't live near those lakes that get the blooms. Okay. Okay, what's the mechanism?